Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take the easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Anklebones by Full Deck and Missing a Few Cards, and here are the rules. Standard Sudoku, cages, and modular lines. So these are normal, typical rule sets in variant Sudoku. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. Modular lines. Any set of 3 adjacent digits along a modular line has 3 different remainders when divided by 3. So, for example, let's say along this line, say this was a 1 and this was, say, a 5 and this was a 6. You have essentially, like, along this, actually, and then let's continue. This would have to be, so for this set of 3 digits, you have 1 that's modulo 0, 1 that's modulo 2, and 1 that's modulo 1. Well, along this 3 set, you would also have to have 3 each from modulo 0, modulo 1, and modulo 2. And we already have 1 from modulo 1 and 1 from modulo 2. So this needs to be from a modulo 3. So or modulo 0, sorry. Not modulo 3. There's no modulo 3 when divided by 3. So let's just say that's 9. And then, for example, these 3 would have to have 1 from modulo 1, modulo 0, and then modulo 2. The one that's missing is modulo 2. So we could say something along the lines of this has to be a 2. And that's an example of how modular line works, right? Because basically you have to have 1 each for any 3 digits along the modular lines, which we have a lot of. You have to have 1 that's from modulo 1, 1 from modulo 2, and 1 from modulo 0. And that's how modular lines work. Cages. Digits in cages cannot repeat and must sum to the values shown in the upper left corner of the cage. So, for example, if this were a 1, this would have to be 3, because these 2 digits must add up to 4. If this were 6, this would have to be 3, because these 2 digits add up to 9. And if this was 2, this was 7. If this is 2, this has to be 7 to add up to 9. These 3 digits must add up to 18. These 2 digits must add up to 13, etc., etc. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so my eye, I'm wondering if I should color all the modulo lines first, or if I should do the cages. Let's do the cages. So this is 1 or 3. This has to, let's go here. This is either 5, 9, or 6, 8 for the 14 cage. Those are only 2 options. This has to be, let's see. Actually, I'm pretty sure that this is actually, yeah. This can be 4, 9. It cannot be 5, 8, because if it's 5, 8, that eliminates both possibilities for this cage, right? Because 5, 8 eliminates 5, 9, and 6, 8. And those are the only possibilities in this 14 cage. So it could also be 6 or 7. Well, interestingly enough, if this is... Actually, we don't know any information about that. Okay, so let's not go there. Now let's start coloring, I guess. Where should we start? Let's go here. So if we start, we're gonna make it red, green, and blue. Actually, we must make it red, green, and yellow. So this is red, green, yellow. This is red, green, and yellow. Okay, so we know there's two yellows along this, and the reason why we know this is, again, every time you have the next three digits in a modular line set, which is any set actually that alternates between three specific digits, three specific sets, right? Anytime you have any line that basically has to have one of each set of a set of numbers, and that's three specific sets, the third set must always be the same as the first one, right? Or yeah, so for example, if you have one, you look two, three. These two have to remain the same, and obviously this has to be the same set as this one, right? So therefore, you know these are the same set, these are the same set, and these are the same set, right? In addition, any three, you always have one of each set. So yellow has to be one of these sets. Therefore, yellow cannot be these two digits. It has to be red or green here. Well, either this is yellow or this is yellow. We're not sure which, right? Um, and I don't know if we have it. This has to be blue, sorry, green or red. And this is green or red, but we're not sure which, right? Yellow has to be one of these two. Yellow has to be one of these two. Um, for this, let's make it pink, pink, orange, and blue. So similarly, this has to be blue, this has to be orange, and this has to be pink. Pink is one of these two, has to be in one of these three cells. So this cannot be pink. This has to be blue or orange. I'm not sure if that's helpful. Um, hmm. Actually, I don't think this coloring is helpful. Okay. One thing we know is 6 and 9 cannot be in the rest of column 5 because we know one of these cells has to have a 6 or 9. It's either 4 9 or 6 7. And one of these cells has to have a 6 or 9. It's either 5 9 or 6 8. So the rest of the column cannot contain 6 or 9. It also can't contain 1 and 3 because of the 1 3 pair here. So the remaining digits have to be 2 4 5 7 8. Right? 2 4 5 7 8. This cell is always going to be modulo 2 or 3. And we're going to designate that as pink and orange. The other one has to be the other one, right? So this is pink or orange. These are pink and not pink, they're orange or green because it's modulo 0 or modulo 1. This is pink or green because it's modulo 0 or modulo 1. So there's no modulo orange in any of the remaining cells. So it has to be green or pink, right? Because there's no 3, 6, or 9 in the remaining cells here. Is that helpful? I'm not really sure. What are these cages? They have to be 1, 7, 2, 6, or 3, 5. Well, those are all the modulos, unfortunately. What about this? This 1, 8, 2, 7, or 3, 6, 4, 5. So 1, 8, 2, 7, 3, 6, or 4, 5. Could be 3, 6. Oh, let's go here. This is either 1, 5 or 2, 4. So this is either modulo 1 or modulo 2, right? If it's 1 and 5, that's modulo 1 and 2. If it's modulo, and this could be 1, 6, 2, 5, or 3, 4. But it can't be 2, 5, actually. So again, this is 1, 5 or 2, 4. If this were 2, 5, that would eliminate both possibilities for this cage, right? 2, 5 eliminates 1, 5 and 2, 4. So this can be only 1, 6 or 3, 4. So this combination can only be modulo 1, which is green, and modulo 0, which is orange. Okay. What does that mean? Well, we know this is the same as uh this set, right? Because it's 3 away from here. So this is green or orange. And this is the same as that set, so this is green or pink. So if this is orange, this becomes green. Yeah, let's look through the possibilities here. If this is orange, this is modulo 3. This has to be 1 or 4. So this would be green. And this would have to be pink. Then what would happen? This would have to be orange because the other one's modulo 3. And then this, so this would be then forced to be orange. This would have to be modulo 2, and this would have to be green, I believe. Right? Right, so this is pink, which is modulo 2. This would have to be modulo 1, and therefore this would be modulo 1. That works fine. If this is pink, what can this be? If this is pink, then this has to be modulo 0. This is pink. So this can no longer be pink. So this one has to be green, which forces this to be orange. That makes this green because it's modulo 1 with modulo 0. And this has to be pink. So then this would be the same. This would be pink. This would be green. Yes, it has to be the same there. Okay, so we know whatever this is. So now we're just going to actually make it that this is a certain color, because otherwise it gets too confusing. This is orange or pink. This is orange and pink, actually. So we're just going to make this this set, right? These are the other sets that it can be. One of these is orange because it's a set of 3 digits. So these cannot be orange. One has to be green here and orange here. This is pink or orange. This is green or orange. We don't know. Do we really have that much information there, though? Green can no longer be here. The rest have to be orange or pink. This is orange or pink. This is orange or pink. What we know about this 18 cage is it cannot be 3, 6, 9 because these have to be different. but we don't know what it can be. It could be something like 189, which would be three different ones. It could be 2, 7, and 9. Hmm. We know 1 and 4 cannot be in the rest of row 8 because either this is 1, 4 or this is 1, 4. Hmm. Hmm. Okay. One thing we know is this has to be some one of each of pink, green, or an orange. So again, orange cannot be here. One of pink has to be here, and one of pink has to be here. Therefore, we know this cannot be pink, and this can't be pink. So the rest have to be green and orange. This is green and orange. This is green and orange. One of each is here. One of these is orange. So at most one of these is orange here. Actually, we know this can't be orange. So one of them exactly has to be orange, which means the other one has to be exactly green. So this has to be a combination of green and pink. But one of them is exactly green, one of them is exactly pink. What does that mean? I'm not really sure. Mm. We don't know if these are the same. We know these are the same. And these are the same. Hmm. Let's see. What else can we figure out about this? It could be 4, 6, and 8 works here. It could be 4, 5, 9. Actually, does it have to be one of each? So we have 189, which has modulo 1, modulo 2, and modulo 0. 279, which is modulo 2, modulo 1, and modulo 0. You cannot have 369, as we said before. 3, 5, and 8. No, 3, 5, 8 does not work. 3, 7, 8 works, which is modulo 0, modulo 1, and modulo 2. Right, so maybe then let's go at a different route then. Let's just start with this. Okay, so let's remove this. Let's start with this one. This is the same as that. These have to be different. So we're going to make that green and green. And then this has to be orange. The thing is, does this have to be orange also, is the question, right? I think so, right? Because so we've tried 279, 189, 369 does not work. 378 is also one of each set. Now we try 4. 4, 5, and 9 is modulo 1, modulo 2, modulo 0. 4, 6, 8 is modulo 1, modulo 0, modulo 2. And that's all the 4s that can work. And then we have 5, 6, and 7 as the other possibility, which is modulo 2, modulo 0, modulo 1. So this is always then orange. This is either green or orange. So this is one of each. What else do we know from this? Um, there's two that are here. Okay, we know if it's ones, these have to be two distinctly different sets. It's 1, 7. Actually, it's not true. It could be 1, 7, which is modulo 1, modulo 1. 2, 6, which is modulo 2, modulo 0. Or 3, 5, which is modulo 2, modulo 0. Hmm. That's interesting. Uh, maybe we should revisit this one then. That was basically guaranteed. Again, the possibilities are 1, 7, 2, 6, or 3, 5. We know, again, we were looking at this as a possibility. Let's make it red, yellow, and blue then. Red, uh, blue, and yellow. This is then red, blue, and yellow, right? We knew this cannot be yellow because one of the yellows has to be here because this is a set of 3 on the modular line. So one of them has to be yellow. So these are both blue and red, which means this has to be, one of these two must be yellow. Well, the other one has to be blue or red. And this then also has to be blue or red, right? Now, the thing is for that is that whatever this set is, since they're both 8, neither of them can be 1, 7, right? If they're 1, 7, the problem is the yellow can't be in this set and in that set if it's 1, 7, right? Because the only modulo 1s left is 4, and 4 can never be in these sets. So whatever this set is, so let's not color these blue and red. Let's specifically color this. We're going to make this red and this blue. That means this has to be, this is red. This has to be a blue with this yellow. And therefore, this must be a blue with this yellow, right? Because there's no other way to for that to work, right? Because if you have you have one set that's part of both of these sets. Well, it can't be modulo 1, so it has to be either modulo 2 or modulo 3. And the other digit with those, so say it's modulo 2, that would be 2 and 5. Well, what are the digits that are specifically with 2 and 5 to add up to 8? It's 6 and 3, which are both modulo 0. So those have to be the same modulo set also, right? So we know then we have one blue here, and one blue here. This is yellow and yellow. This must be yellow and red because we have 3 blues already. The remaining sets are specifically yellow and red. Well, can this ever be red? No, because it has to be 3 of one for every 3 cells on the modular line. You have to have one of each color or one of each set. So this has to be yellow, which makes this red. That means this can't be yellow, so this must be the blue, which means this can't be blue, this must be yellow. Therefore, this is blue, this is red, this has to be yellow then, to continue. This has to be blue, this is red, and this is yellow, which makes this a blue. Now this, the remaining digits here are blue and red. We're not sure which, though. This has to be blue, and this has to be red. Interesting. Okay. So this is 2, 6, or 3, 5. This is 2, 6, or 3, 5. And this cannot be, this red has to be modulo 1. So therefore, this has to be 4, 7, which forces this to be 6, 9. So we know the blues are modulo 0. So therefore, this is 3 and 6. The yellows are modulo 2, so it's 2 and 5. This is 2 and 5. This has to be 3 and 6. So this is the remaining one, which is a 9. This has to be 1, 4, or 7. This is 1, 4, or 7. This is 1, 4, or 7. This has to be yellow, which is 2, 5, or 8. Well, what can be with that? It could be 7, 4, or 1 with that. So this has to be specifically red, right? 8 and 1, 4, 5 and 4, and 2 and 7. This has to be 3 or 6, which means what is with that? It's specifically 1 or 4, which is modulo 1. So this is red. And that just so happens to turn out correctly, or well. This red has to be here, so this is red, which makes this 1, 4, or 7. 1, 4, 7 adds up with to 9 with 2, 5, and 8 also. So this is also yellow here. This is red, which forces this to be the last red in the column. This has to be... Alright, no, this can't be red. Yes, this has to be... Sorry, this has to be red and this has to be yellow, because those are the only remaining digits, which makes this blue, which makes this a 3, and that makes this a 1. This has to be 4 and 7. This has to be 2, 5, or 8. We don't know which. The remaining digits now have to be blue, because those are the only digits left in row 6, right? We already have 3 yellows and 3 reds. And they're required because this has to be 3 away from here, which is red. This has to be 3 away from here, which has to be yellow. So these are both blue, which means actually we now know what colors these are. This has to be yellow to have 3 of each color. This is blue, and this has to be yellow. This has to be red. This is red, and this is blue. We have 1 of each set here, so this cannot be red. This has to be blue, which makes this not blue. This is red. Because we already had 2 reds here. 1 of the reds also has to be here. 1 of the blues has to be here, which means this can't be blue or red. It has to be yellow then. So this is yellow. This is red because it's a 1. This has to be 4 or 7 here. Either this is 1 and this is 8, or this is 1, this is 8. So this cannot be 8. It's 2 or 5. This is 2, 5, or 8. That means we have one of these is a red and the other one's blue, which forces this to be yellow. This is red or blue, but this specifically cannot be blue because it's only 1, 5, or 2, 4, and there's no zero modulo z. There's no 0 mod 3, so this has to be red, which makes this not red, which makes this a red, which makes this not red. So this is red, which forces this to be 1 or 4, which has to be with 2 and 5. This 2 and 5 is a yellow. So this cannot be yellow. This has to be blue then, which is 6 or 9. So this is 5 or 8, which forces this to be a yellow. This has to be a red then, which is the 1 and 4. Therefore, this can't be 1, 4. This has to be 3 or 6, which makes this a blue. So this has to be blue. This has to be 1 or 7. And this also has to be 1 or 7 to add up to 8. So therefore, this is a red. This is red, which forces this to be red, and this must be yellow. This has to be a 4. Oops. This has to be a 4, because that's the only digit left possible in the box. This can't be 4 then. which means this can't be 5. This has to be a 7 because it's the only 1 modulo 3 left. So these two must add up to 11. So it's either 9 here, 9, 2, 5, 6, or 3, 8. That's fine. This can't be 7, so this can't be 2 here. This has to be an 8. Because that's the only digit remaining in box 1 for the 2 modulo 3. This cannot have 2 reds. So this cannot be red, and this cannot be red. Therefore, this must be a red here. Which leaves this as 4 or 7. So the 4, we now have a 4, 7, 4, 7 pair in column 5. We also have a 3, 6, a 6, 9, 6, 9 pair. So this has to be then not 4, 7, or 6, 9. So it's 2, 5, and 8, which means those are both yellow. Remaining digits, this could be, this can't be red, this can't be red, therefore where is the red? It has to be here. This is blue or yellow, this is blue or yellow. We don't have that many possibilities here. Red cannot be either of these. Or can red be? It's one of those two. We don't know. This is either blue or yellow, but we don't know which. This can't be 7, therefore this is 4, which forces this to be 1. This 1 has to go with the 6 to add up to 7. So this can't be 1, this is 4, which makes this a 2. This then has to be a 1, because that's the only digit remaining. We don't know where the 7... This can't be 4, so this has to be a 7, which makes this a 6. That means this can't be 6, so this is 9, and this has to be 5. Which means this can't be 5. This is a 2, 8 pair here. Remaining digits in row 8 are 3, 8, and 9. This has to be 3 then, because it can't be 9, because of this 9 here. So this is 3. And this is 8 or 9. And this is 8 or 9. Okay. This can't be 9. This is 3 or 6. This is 2, 5, or 8. This is 2, 5, or 8. The remaining digits in box 8 have to be 3, 5, 6, or 8. No, 3, 6, 7, 8. And we know 7 can't be here. We also know one of these has to be yellow. So the 8 has to be here, which means this can't be 8 and this can't be 8. What are the remaining digits here? 2, 5, 8, and 9. This is 2, 5, 8, and 9. This can't be 8 here. This has to be a 6. Because that's the only digit remaining. This can't be 6 because it can't be here. This can't be 3 because of that 3. So this is a 9, which makes that a 6. This is specifically 3 or 9. What other stuff do we have? This has to be a 3 because that's the only digit remaining that is 0 modulo 3 because we have a 6 and a 9. Therefore, this can't be 3. This has to be 9, which forces this to be a 6, which makes this a 5. So we have 5, 6 here. This can't be 5. This cannot be a 6, so now we know it's a 3, 8, 3, 8 pair. This can't be 5, so this is now 2 or 9. This is 2 or 9, but we don't know which one is which. This can't be 3, therefore this must be a 6, which makes this 1. That makes this 4, which makes that 5. This can no longer be 5, so this is 2. This can't be 4, so this is a 7. This can't be 7, so this is 1. This makes that an 8. This cannot be an 8, then. This can't be 2, so this has to be an 8, which makes this a 2, which means this can't be 2. This is 5, and this has to be 3. Since this is 5, this makes that a 2, which makes that a 6. 9 cannot be any of these now, so this has to be an 8. This can't be 2, 8, or 9, so this has to be a 5, which makes that a 2, which makes that a 9. So now we know these are both yellow. And this can't be a yellow because it's not 8, so this is blue, which makes this a yellow. This has to be blue, which makes that blue, and therefore this has to be yellow. Whoops, not blue, yellow. So this is 2, which makes this 8. This 8 makes this a 9. This can't be 6, so this is 3. This can't be 8, so this is 3 because it's 0 mod 3. This has to be an 8. This can't be 3. This can't be 3. This has to be a 5 because that's the only 2 mod 3 left in the column. This has to be 2 or 5. This is 2 or 5. We know the remaining digits here have to be yellow because there's no other place for it. There's no other common. This has to be 7 because it's the last 1 mod. 3. This can't be 7 then. This can't be 7. This can't be 1 because of this 1, so this must be 4, which makes this a 1. That makes this 7, which makes that 1. This 7 makes this a 4. So these are both yellow. One of these is blue, one of these is red. We don't know which is which. We have 3. This has to be an 8 because that's the only. This has to be a 2. This has to be 8 because it's the only 2 mod 3 left in the column. This has to be a 2 because this is 5, which makes this a 5. Well, where's the last 2 then? The last 2, we know this has to be a 2 now because 2 cannot be here, here, or here, so this is a 2. And we now have 8 2s. Well, we should be able to figure out where the last 2 is. It has to be here. So this is a 2, which makes this yellow. This then has to be a 5, not pink, a 5. This can't be 7 because of this 7, so this must be a 6, which makes that 7. So this is a blue, and this is red. Where is the last 5? I think we have a lot of 5s. We have 8 5s. We do have 8 5s. The last 5 we should know is specifically here. So this is a 5, which makes that the last yellow in box 5. Where's a 4 then in box 5? Can't be any of these. It has to be here. So this is 4 and therefore a red. The remaining digits are 6 and 9, so they're both blue. So this is blue and this is blue. Right. This can't be 6, so this must be the 9, which makes this a 6. This last digit has to be in column 4, has to be blue also. And therefore this is a 9, which makes this a 3. We have 2 reds and 2 yellows we're looking for. Sorry, one red and 1 yellow left in box 2. This has to be, this cannot be 1 or 4, and it can't be 7, so this can't be any of the reds, so this has to be the yellow, which makes this an 8. This has to be a red, and this can't be 1 or 7, so this must be a 4, which makes this a 1, which makes this a 4. The remaining digit here has to be a 9, and is therefore a blue. So we have 3 blues now. Now we're missing 2 reds. So they're both red. This also has to be a red, and it has to be the 7. The remaining digits here are yellow and blue, but are specifically 3 and 8, and this cannot be 8, so this must be the 3, which makes this a blue. This is a yellow, and this has to be 8. This 3 cannot be here, so this must be the 3 as the only place. So this is 3, which makes that a blue, and therefore this is a red. And now we fill in the rest with Sudoku. This has to be a 7, because that's the only digit remaining. This has to be a 1, and this must be a 7. And that's how you solve it. Yeah, very interesting, actually. Is particularly this part, right? So I'm not sure how you can see it immediately. Because this was a little convoluted getting here, which showed that this would have to be a certain thing. And then this would have to have something from both sets. From one set, and then they could not be the same set here. Well, it couldn't be the same set here anyways, because one of these sets had to be in both of these 8s, right? That was really the break-in here, was that the 8s had to share one set, essentially. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.